Okay, so today we'll be starting a new series. Basically, we want to answer the core question of, can we build an automated robot fleet from scratch, and can we do it with low-cost components? What are the limitations? So essentially our challenge will be, first of all, we need to build a robot tank. Then we need to have a software to communicate with a tank, and then we need to be able to follow specific directions and a route. So let's say, for example, we want to make this drive from point A to point B in a city. It needs to be able to get the exact directions and the path that it needs to follow. So yeah, it's quite possibly a daunting challenge, but it is something that in 50 years time or so it will be quite a common thing, in my view, at least what I foresee. Automated vehicles driving around, it shouldn't be, it's not too far-fetched. It's just the safety concerns around it. And that's kind of exactly what we're going to test with this, is we're going to take a robot, or we're going to build a robot, and we're going to see, with the technology that we have off the shelf, what can we achieve? I don't expect any spectacular results. It would require some refinement and so, but we're going to try to do it as cheap as possible, and then see what the limitations are, and then upgrade as we need to go. So that's a challenge. Whether we succeed or not, that is a different question altogether. But so let's get started. Okay, so to build our robo taxi / robot, we need a couple of components. So we need to decide on what are we going to use. So the first thing that I've got is we're going to use our tank chassis as a basis. So let's say that will be our basic control, or our platform. So to control this, we essentially need essentially needs a motor driver, or specifically a motor driver that can control two motors, because there's one motor on each track of this tank. So therefore we're using the L298 module. That should be more than sufficient to handle everything needed for this. I really like this module. It has some nice benefits. For example, you can input a voltage, let's say 12 volts, and you get an output. It acts as a regulator as well. So you can, let's say, power some things that require 5 volts and high amperage as well. So just saying, that is a possibility. But we're going to use that to control the two motors. By zooming into this, we can see that our two motors will be connected on the side, our communication channels and our power supply. So that's a basis to control the tracks. Next up, we essentially need something to control the motor driver, to tell it how fast to drive, and just basic controls. So therefore we're going to use either Arduino Uno or Arduino Nano or Arduino Mega. In this case I went to a Mega, and that will be our control the logic for the tank. Okay, so then next up, to power all of this, we need batteries as well. So we've got a couple of choices of batteries. I'll be going with a popular 18650 batteries, and then what we will be, so that essentially will connect and provide power to our tank. So now we've got a couple of options. Obviously your tank, the amount of time you can use it before it needs to be recharged obviously depends on the capacity of batteries that you're using and the quantity of batteries, but essentially it comes down to your batteries. So we might opt for more, but we'll start off with a simple setup. then we basically need a way to charge these batteries as well. Now there's one or two components that we can use depending on whether we're going to use, let's say, 3 batteries to run our tank, or whether we're happy to just use 1 battery to run the tank. This obviously makes a big difference in how long the tank will be operable before we need to recharge the batteries. So essentially, I'll put 2 components down here. But essentially, we've got this popular component. If we want to handle 3 batteries, or multiple batteries, or we can use this very simple device, which provides a 5-volt output. We'll get back to that in a second, because now we do have a choice. So we've got either one of these 2 components to charge up our battery and essentially provide power to our tanks. Now at this point we need to investigate to understand how much voltage do the motors expect to work at. If you provide with too little volts, essentially there's too little power, and your motor won't be, it won't have enough torque to go anywhere, and speed as well. So, but if you provide it with too much voltage, it will overheat, and a wire may burn out. So it is a very delicate balance, and you also need to keep in mind that let's say if your tank or your motors, if they are in operation, if you put a load on them, they require more voltage, and if they're at a point where the motor stalls, that there's so much force, or it's pushing against something, or whatever case, and the motor stalls, it uses an extremely high amount of current as well. So that is a high risk for burning out any thin wires, and also the motor itself. So that's something to take into concern. So therefore, if we do go with the we've got 1 BMS, so it is 5 volts. So we know it can't go more than 5 volts, and we've got the other BMS that can go up to 12 volts. But when I look at the tank at the bottom of it, it shows that it has space for a 7.4 volt battery, 7.2. But in case it is, it's not more than 7 volts. So 12 volts will be too high, so either we need to bridge it out and only use 2 of these batteries, then we'll get to 8 volts, or even just 1 battery. But when that defeats the point, then we might as well just use a component that's already just uses 1 battery, or we can put a step-down converter in and a regulator to bring the voltage down to the voltage that we essentially require. So that would be the power supply of it. So next up we need to essentially we need to be able to now do something smart with this tank. On its own it can't do, with these components you'll be able to do something, let's say hard code it to do something specific, but it doesn't know where it is in the world, it doesn't know any information, there's no sensors on it per se, and we've got no way to send it commands. So the next step from our side would be to, first of all, we would want to include a way to communicate with it, and for it to communicate with the outside world. So therefore we're essentially adding a GSM module, or just basically the same thing as a cell phone, which will handle the logic, or at least allow us to communicate with the outside world. So we'll either use this. There is also the A9 GSM module, which I highly recommend, but in this case we'll start off with a SIM 800 as a test, and so see if we need to change it out. So now with this, all of these components that you see here, it would be able to communicate with the outside world, but it still does not have any nice way for it to basically determine either where it is or which direction it is facing. So next up would be for us to to add a GPS module. So there are quite a few of them on the market. We'll go for the Neo 6, which I'll add in a second. So the Neo 6 is it's accurate. It's not your most accurate GPS module that you can get, but this will allow it to, at this point now, speak to the outside world. So with this, it would allow it to get the location and then with the GPS, and then communicate with the outside world using the GSM module. Okay, but still at this point the GPS will only tell us our coordinates and not really any more information such as which direction are we looking, how fast. Okay, it will tell you how fast you're traveling, but it's not that accurate per se. So the next most important component at this point would be to add an IMU. So this is just a system. You get various IMUs. Essentially what they do is they allow you to get information on various axes. You get a 3-axis IMU, 6-axis and a 9-axis, and what it does is just to measure on all all your different, let's say it acts as a gyroscope, and then also detects a magnetic field, and then also it allows you to determine your orientation exactly. So the thing is, if you just have a accelerometer, okay, and then there's accelerometer. So it's accelerometer, gyroscope, and I'm not sure if it's called a magnetometer, but yeah, it reads a magnetic field. So with that set of information, you're able to determine your direction in the world, which way you're looking, and what your orientation is. You get IMUs that's just, let's say, 3-axis. Let's say then it will just detect a magnetic field or just your acceleration. But with this, we'll be able to detect our acceleration, the magnetic orientation, and as well as our own rotation. So those are fairly important information if we want to be able to navigate through the world. So because our GPS signal will just tell us where we are, but if we want to drive forward to a specific direction, we need to know which way we are facing, which way we need to turn, so if we look at the right direction, and then we can move forward. So essentially what the components that we're going to be working with to start off with is basically everything that you see on screen here at the moment as is. So we'll see if we can get this converted. Okay, the question would still just be, are we going to use, or which BMS we're going to use? But to start off with, we'll start off with a small one just to test the concept and allow it to work out. So, and at this point, this system will communicate out to our drop time system that we developed in our internal project, and yeah, that's it basically. So that's the first step. So let's get started. Let's get all the components. So in the next part, we'll be covering these components as individuals, as needed. And then we'll be putting it all together, and then we'll be getting the software up and running, and we'll getting the pathing in place, and then we'll do a final test. So stay tuned. The next episode will be coming soon.